Hi kiddos, here's your midterm review video. I'm probably going to try to do maybe every other problem or maybe a little bit less. So you have an example to go through, and then if you need some extra support you can come and get some of that. For numbers 1 through 4 we're doing some factoring. And here what we're really trying to do is that A times C factoring. We're going to have negative 2 for 1 times negative 2. And b is going to be 1 because we've got 1b going on here. We try to multiply to things that give us negative 2 and add up to 1. First thing we try to get to 2 is going to be a 1 and a 2, so it might be a positive 2 and a negative 1, and that's what happens to work. Okay, that means that we'd have v squared plus 2v minus 1v minus 2. My first two have a v in common, leaving us with v and a plus 2. And for my second two, I can take the minus 1 out, leaving me with v plus 2 as well. That gives me a v plus plus 2, that's fun. A v plus 2, and the leftovers would be v minus 1, which happens to be a. If you got stuck here and you weren't sure what to do, you could also check each answer by doing double distribution and seeing which one matches what you get. For number 5, we're looking at the quadratic formula. I know because it says use the quadratic formula, but also these numbers don't come out so nice. So I know the quadratic formula, which you are given on the exam, is x equals negative b over 2a plus or minus the square root b squared minus 4ac all over 2a. So for this problem, we've got a equals 1, b equals negative 9, and c equals negative 9. So when I plug some stuff in, we get negative 9 over 2 times 1 is 2. So we get 9 over 2. And all four of those have that as part of our thing, so I'm going to keep going. Then we have plus or minus. We got the square root of b squared, so negative 9. I'm going to put that in parentheses. That's really important. And then minus 4 times 1 times negative 9. That's going to be all over 2 as well. So that's square root of 81 plus 36 over 2. 81 plus 36 is going to be 117. And that looks like what we've got for C. Some of these answers are designed to trick you because a lot of times we forget the parentheses in here. And then you have negative 81 plus 36, which would give us that negative 45 then. Tricky, tricky. Jumping over to, let's do number 9. This is simplifying when we have imaginary numbers involved. Really, this is just combining like terms, so negative 3 minus negative 7. I like how I said that backwards even though I was underlining things. Negative 7 minus negative 3, which is negative 4. Then we've got negative 2i minus negative 3i, so that's plus plus, which is going to be 1i. So negative 4 plus 1i, and we're done. That one will be multiple choice on your exam. Something in these went wrong, so I couldn't get these to be multiple choice in this file. For number 13, we've got to distribute this 2 first to all 3 pieces. Remember that 2 in front has a 1. So this is going to become 2 squared times a to the 8th times b to the 4th times a to the 3rd. I'm going to add the exponents for when I'm multiplying. So we get 4, a to the 11th, and b to the 4th, which happens to be answer choice C. For number 17, we're going to do some double distribution. R times R is R cubed. R times minus 2R is minus 2R squared, and R times minus 3 is minus 3R. Minus 3 times R squared is minus 3R squared. Minus 3 times minus 2R is plus 6R. And minus 3 times minus 3 is plus 9. And we add down, so we get R cubed minus 5R squared. We only have one answer that has both of those, but let's just double check. Plus negative 3R plus 6R is going to be 3R. Yes, we're still good. And then plus 9. B is our winner. For number 21, I'd like you to notice that this is x squared and x to the fourth. Therefore, this is quadratic-like. The powers are double each other. I'm just going to complete this by factoring using grouping as we normally do. So we got a times c, negative 42, and add up to negative 1. So times and plus. Alright, so things that multiply by 42, I know 6 and 7 do, and then 6 and negative 7 also get us to 1. That's pretty cool. So that would be x to the 4, and then we'd have plus 6x minus 7x, and those should be squared because they were originally squared, and then minus 42. Okay, for the first two, I'm going to take an x squared out. We have x squared plus 6. Then I'm going to take a minus 7 out, and I'm left with x squared plus 6. So that gives me x squared minus 7 and x squared plus 6. Neither of those is factorable any further, so we are done. So minus 7 and plus 6 is our winner. Alright, for number 25, we got to find all zeros and then sketch a graph. It's already factored for us, so that gives us x equals 0, x equals negative 5 over 3, and then x is equal to negative 3. As far as sketching a graph, I'm going to put these 3 zeros on. So negative 5/3, negative 3, and 0. We've got leading coefficients of positive values. We're going to go up and to the right, and then with a nice smooth curve, we are done. This would be multiple choice, so each of the graphs would give you a list of the zeros and give you the graph to match or not match. Okay, for number 29, we're looking at a quadratic function vertex form that's going to pass through the given point. First thing that you need to know is that the vertex shows up in this vertex form as coordinates inside of the equation, where the h should be the x and the k would be the y coordinate. So we're looking for something. There's also a number up front, but we'll talk about that in a second. We're looking for something like an x minus 2 squared and a plus 2 on the outside. Inside the parentheses, things are always opposite, and outside they are always the number that we start with. Just kind of strategically, that gets rid of 2 of our answer choices. Then the last part is we've got to pass through the point 1, 1. You'll also have a picture in this problem on your test. So we're looking at a vertex at 2, 2, and passes through the point 1, 1, which is 1 down and 1 over. That means we're looking at a negative 1 as our leading coefficient, and choice D is our value. I couldn't get to the D because something on my screen's in the way, but don't worry about it. I guess you could also have plugged in the point 1, 1. and have seen that. We've been doing that with x-intercepts and polynomials recently. For number 33, we got 3k squared. Ooh, I almost went to the wrong ones, and these are in different order. That's fun. So 3k squared minus 6k squared, and then negative 4k to the third minus negative 3k to the third, and then we've got 8, nothing goes with that, and then nothing minus 6k. Okay, so that gives us negative 6k squared. And by that I mean negative 3k squared. Negative 4 minus negative 3 is going to be plus 1k to the third, and then plus an 8 and a minus a 6k. Looking at, so it should be a minus k to the third. One of this one, and that is our winner. Has all of those pieces. All right. Find the vertex of each. Okay, that's going to be 6, comma, positive 1. I did the opposite for the inside, and then the natural value on the outside. So 6, comma, 1 is going to be here. Leading coefficient is 1, so I'm going to go up 1 on both sides. Sketch a graph. Bam. Alright, next we got some more exponent rules. I'm going to make sure I put a 1 on my 2. Distribute that power to all of these pieces. That would become x to the 6 over 2 to the second, x to the 8th, y to the 8th. One of the strategies we've talked about if you have an x and an x is to kind of subtract backwards from the bottom to the top, and it stays in the bottom instead. 2 squared is 4. 8 minus 6 would be x squared, then y to the 8th. Number 45. Finding the inverse means that we've got to switch our x and y variables and use different ones here, which is kind of annoying. But I'll keep this as y and n. So y is equal to negative 2n plus 4. And then we know we need to switch our n and our y. So n equals negative 2y plus 4. Get the new y by itself. We get n minus 4 is equal to negative 2y. Divide by negative 2 on both sides. And that's going to be the one for our answer. I don't see one that's quite exactly that, so let's see if I can go a little bit further. So negative n over 2 is the same thing as n divided by negative 2. Negative 4 divided by negative 2 would be plus 2. And this would be the inverse of g of n. Negative n over 2 is the same as negative 1/2 of n. And then we get plus 2 for that. All right. For 49, we've got to compare the graph of g of x, x to the 3 minus 8, and f of x, which is x to the 3. Well, minus 8 means a translation of down 8. So I'd say something like g of x is translated down 8 units or 8 units lower than f of x. Something kind of in those words. I think I'll do another one of these, maybe number 52, because that has some more complicated pieces. To get from x to the fourth to this mess over here, it's a vertical stretch by a factor of 3. That's that number out front. It's also going to be 5 right for the x minus 5, and then 2 down for the minus 2 at the end. Alright, for number 55, we've got to write a polynomial that could have the graph shown. Actually, do number 57, I think, because that looks more fun with the graph and stuff. So we've got x-intercepts, -5, -3, and 1. I also see that that's got a bounce at -3. So I'm going to start off by saying that y is equal to, leave a space for some kind of an a value, x plus 5, x plus 3, we're going to square that for the bounce, and then x minus 1. I then have to check to see what's going on for that a value, and to do that I'm going to use a y-intercept. So -45 is equal to a times 5, plug in 0 for x, 0 plus 3 is 3, 3 squared, and then 0 minus 1 is minus 1. 3 squared is 9, 45 times -1, that means that a is going to be 1. We got our value automatically. So that means that we're done at that point. For number 59, we're looking at the equation for a circle. I'm going to start by finding the center here. The center is at 1, 2. That means that my equation should have an x minus 1 squared and a y minus 2 squared. That happens to be this, but let's just make sure. So we got 1, 2, 3. R equals 3. We know this has got to be r squared, 3 squared, which is 9. Okay, that works. For number 63, we've got to divide this and figure out what the remainder is. So that's going to be x plus 4 dividing, and then we got x to the third plus 3x squared minus 5x and minus 9. Alright, to get from x to the third is going to be x squared. Going to multiply that down to give us x to the third plus 4x squared. When I subtract, I get 0 and I get minus 1. Bring down the next piece, which is minus 5x. Okay, minus 1. When I distribute that down, sorry, minus 1x, we're going to have minus 1x squared and minus 4x. When I subtract those, got 0 and -5 minus -4 is minus 1x. Bring down the minus 9. And then finally, to get from x to minus 1x is going to be minus 1. Distribute that down, and we're going to have a minus x and a minus 4. Subtract 0, and we've got -9 minus -4 is going to be minus 5. So you get minus 5 over x plus 4. If you were interested in using synthetic division for this, we're going to have a minus 4 out front, and then our coefficients are 1, 3, -5, and -9. We're going to bring down the first number. And when we do that, we've got 1. -4 times 1 is -4. Gives us -1. -4 times -1 is 4. -5 plus 4 is going to be -1. -4 times -1 is going to be positive 4. Leaving us with -5 as our remainder. So we've got negative 5 over x plus 4. Then we get the number, so minus 1, minus 1x for our x, and 1x squared for our x squared. Alright, for number 67, by the way, you might notice that we're beginning to transition into all free response from here forward. These are all going to be free response type questions up until the very end. So we've got v cubed minus 2v squared minus 12v plus 19 divided by v minus 4. I kind of regret my placement for this in a minute, I think. Especially if I don't write that as 19 in here. So I'm not going to be able to see things when I start to divide. Okay, so it's going to be v squared. Multiplying down, we get v to the third minus 4v squared. Subtracting, we've got 0 and plus 2v squared. Bring down the minus 12v. So then we've got plus 2v. Multiplying that down, we've got 2v squared. And minus 8v. When we subtract, we get 0, and negative 12 minus negative 8 is minus 4v, and we got to bring down that plus 19. For the last dividing part, we got negative 4. We distribute that. We've got minus 4v, and then plus 16. When we subtract, we get 0 and 3. So it's going to be plus 3 over v minus 4. At that point, you are done. For number 71, we got to convert this to vertex form by completing the square. First thing we're going to do is to take a look at that middle number and divide it by 2. So if I do that, this is going to end up being 20 divided by 2, which is 10. And I've got to square it. And with 20 divided by 2 is 10. 10 squared is going to be 100. I want this c value to be 100. And in order for us to do that, we've got to add 53 to both sides. So we're going to have y plus 53 is equal to p squared plus 20p plus 100. When I factor the right side, that gives me p squared. That gives me p plus 10 squared. There we go. And to get the y by itself, I'm going to minus 53 to both sides. Leave me with this, a lovely answer. For number 75, I've got to get the absolute value by itself first. So I'm going to minus 8 to both sides. And when I do that, I get 6 times the absolute value of n plus 3 is equal to 66. If I divide both sides by 6, I get the absolute value of n plus 3 is equal to 11. That's going to give us two different solutions. N plus 3 is equal to 11 if the stuff on the inside is going to be positive. And then we're going to have a negative solution where we have negative n minus 3 is equal to 11. That gives us n is equal to 8. Then if I add 3, that's going to be 14. So we get negative n is equal to 14, which means that n is equal to negative 14 as our other answer. For number 79, I've got 4 pieces and I'm being asked to factor. I'm going to do factoring by grouping for this because I've already got 4 pieces set up for me. First two I can take an n squared out, leaving me with 2n plus 3. Then I can take a negative 2 out, and I've got negative 3 out, 2n plus 3. And then we've got n squared minus 3 and 2n plus 3. To find all the zeros, we've got to do n squared minus 3 is equal to 0. That leaves me with n is equal to plus or minus the square root of 3. And we've got 2n plus 3 is equal to 0, which leaves me with n is equal to negative 3 over 2. A lot of problems on this page. Okay, next up we've got to sketch a graph, and you're also asked to create a table. First thing I'm going to do is to find the vertex, so that's going to be at negative 3 comma negative 4. I'm going to make that the middle of my table. I'm going to go up 1 on either side to get to negative 2 and negative 4. And when I do that, I'm going to find I get negative 5 and negative 5 as an answer for both of these. So negative 3 comma negative 4. Going down 1 on either side to get an upside down V. It's very important that you do the absolute value as a V graph and not a U graph. This is not a prep. Alright, for number 87, we've got a few different pieces going on here. The first is we have to factor. In other words, looking at this has 4 pieces, we're going to use grouping as our method of factoring. Then we got to find all zeros, sketch a graph, describe the end behavior. So lots of different pieces. Okay, I'm going to take an x squared out of the both first pieces, leaving me with x plus 4. Then on the next one, I'm going to take minus 3, leaving me with x plus 4. Giving me x squared minus 3 and x plus 4 as my factored pieces. My first zero is going to be x squared is equal to 3. X is equal to plus or minus the square root of 3. And then we've got x plus 4 equals 0, which means that x is equal to negative 4. Sketching a graph. We're going to have plus or minus the square root of 3. And then minus 4. Y-intercept, if I plug in 0, I get negative 12. And I know this is a positive leading coefficient, so that I'm going up and to the right. Alright, going through all of these, hitting these nicely, I make something that looks like this. And then for the end behavior, as x approaches infinity as we go to the right, that's over here, y is approaching infinity, in other words, y is going up. On the left side, as x approaches negative infinity, y is going down, so y approaches negative infinity as well. Okay, for number 91, we've got a graph that you've got to make some sense of. And you've got to do a whole bunch of different things for this. First off is identify when the function is increasing. And I'd like to remind you that increasing means a positive slope. In other words, we're going up and to the right. It looks like the only section that this is happening for this graph is right here. And we're going to describe this in 2 different ways. I'm going to describe this using an inequality and then using interval notation. So first I'd say that we're going from negative 3 to negative 1. We always use x values. I'm going to put an x in the middle and put the inequalities in the way they go. It's not a big deal if you use less than or equals. Both of those end up giving us the same information. So if you want to make this like this, that would be fine. There's people who argue about this, but it's not that big of a deal. The other piece of this is interval notation. I'm going to use the same 2 x values. I'm just going to take away the x and the inequalities. And based on what I have now, that would be the interval from negative 3 to negative 1. And that's part 1. Decreasing means we're looking at a negative slope. In other words, wherever our graph is going down and to the right. We have two different intervals that it's doing this. The first is that first part on the left, and then the second is the second part that we're going down. So I might do something like this, where I say we're decreasing from -6 to -3. Again, those are the x values. And then we're decreasing from -1 to 5, and again, those are the x values. Alright, third part's asking for a local maximum. That's any point on our graph that we're at the top before we start going back down. We've got two of them. One is a local maximum because all the other points are lower than it, and the other just happens to be an end point, so we can't see if it's anything to the left. So -1, 4 is the best answer, and -6, 5 is also true. And finally we get to local minimum, and those are any points that are at the bottom of their respective segment, and that would be -3, 1, and 5, -3. And again, one of those happens to be an endpoint, and one of those is just a local value. Next up, we got some word problems. There are going to be ones that are similar to each of these on your midterms. This would be a good idea to get a pretty good understanding of what's going on here. Maybe include something like this on your reference sheet. So first off, we're talking about Angel Falls in Venezuela. We're given a function that models the height of an object after it's dropped off the waterfall. So this goes back to when we were talking about quadratic functions and trying to come up with meaning for different ideas. Hit the ground, we want to think about, okay, this is an x-intercept. In other words, this is when 0 is equal to -16 t squared plus 3212. The easiest path for us would be to minus 3212 to both sides. So we get -3212 is equal to -16 t squared. And then if you divide those two, so 3212 divided by 16, you get that t squared is equal to 200.75. That means that when I take the square root of both sides, we're going to have t is equal to, sorry, I got to get this on my screen, okay, 14.169 seconds. I also would accept square root of 200.75 as an answer. I also would accept you doing the quadratic formula, where in this case a is equal to -16, b is equal to 0, there is no x term, and c is 3212. And that would come out okay as well. Part B is actually an easier question than Part A. It asks us, what is the height 5 seconds after it's dropped? In other words, t equals 5. So what we're doing is plugging this in. So -16 times t squared, and this is going to be times 5 squared, and then plus 3212. 5 squared is going to be 25. 16 times 25 is going to be -400 plus 3212, and that gives us 2812 feet as our answer. The last part is the same exact question as the first question, but now we're having a different equation. This is what happens instead of just dropping it off the side. We throw it up first, and then watch it come down. And the only thing that I might suggest would be a helpful thing. So we know is we're trying to hit the ground, and that's going to be -16t squared plus 32t plus 3212. I think it's probably a little bit easier on us if we divide the whole thing by -16. And the reason I think this is a good idea is that we get numbers that are much easier for us to deal with, like 1. minus 2t, and then we got minus 200.75 like we did in the first part. I think these are much nicer numbers to work with. This is not going to be factorable. We got to use the quadratic formula, or completing the square if you really wanted to. And we have an a of 1, a b of negative 2, and a c of negative 200.75. So when we do that, we're going to have positive 2 over 2, plus or minus the square root, and that's going to be 2 squared is 4, plus 4 times this thing, which is going to be 803, and that's also divided by 2. So we get 1 plus or minus the square root of 807 over 2, also totally fine if you more or less leave this like this. The big issue here is that the negative answer would give you a negative time value, so that doesn't make sense. Sometimes it's better to get these as decimals, and when you do that, so 1 plus square root of 807, and then divide by 2. That's going to be 15.203 seconds. For number 96, we're building a set of boxes to store my Legos, but I spilled coffee and can't read the diagram. So a box is going to look something like this. And it's telling us that the bottom of the box is square. And it's saying that the height is x, and the width is 4 inches longer. So we're going to call that x plus 4. I'm going to call that x plus 4. Dimensions will be given to you on your midterm, so you'd see a picture like this labeled to kind of help you figure these things out. The big idea is that volume is length times width times height. So in this case, we've got volume is going to be x plus 4 times x plus 4 times x. And for your midterm, this is going to be enough. The next step is going to give you an equation to work with that's based on this, but I'm going to multiply this out. And we've got x squared plus 4x, and each of those is going to get an extra x from the end, so it's going to be x cubed plus 4x squared, and then plus a 4x squared plus 16x. So we end up getting x cubed, those two combine to give us plus 8x squared plus 16x. And then for part B, we've got to use a specific volume, and that's going to be 72 cubic inches. So instead of V, I'm going to write 72 is equal to x cubed plus 8x plus 16, sorry, it should be squared. And then I'm going to bring 72 to this side, and we end up getting something like this. And this is not going to be factorable by grouping, which is not what I had intended for this. So give me 1 minute. So the second that I took was to figure out one of the zeros for this, and I figured that x equals 2 is a 0, which means that x minus 2 divides nicely into this. I'm going to do some synthetic division, and this will be 1, 8, 16, negative 72. So that's going to bring down the 1, 2, 10, 20, 36, 72, and 0. And when we do this, we get x minus 2, and that's going to be x squared plus 10x plus 36. This lovely thing is A, not factorable, and B, if you did the b squared minus 4ac on this, you get 100 minus 108. I'm sorry, 100 minus 144, which is less than 0, this part's all imaginary. The one that you have on your exam, it will be factorable, so you don't have to deal with this mess of a thing, or even dividing. It's going to be factorable by grouping so that you can do that much more straightforwardly. And when we have something like this, we're going to have one real solution, and that's because we got one factor that came out nice. So x minus 2 equals 0. I like how I wrote 20. And that gives us x equals 2 as our value. To verify this, I'm going to plug it back in. So we get 2 times 2 plus 4 is 6, times 2 plus 4 is 6, and you get 72. Since this part does not factor, and you got this for the discriminant, or when you try to solve it, if it's something like x squared plus 16 or something, you're going to get imaginary numbers. So that would be an example of why those things don't work. For number 97, this is going to be a really kind of unusual type of question for us. We haven't seen these yet this year. And the goal here is to figure out every possible true statement about this graph. And there's going to be more than one, and you got to figure out all of the true statements in order to get full credit for this. The way this is going to work is there might be like 4 points for this. You get 1 point for each correct statement that you circle, and you get minus a point for each incorrect statement that you circle. So you could potentially get 4 points by getting all 4 right, and then lose some by choosing a couple that aren't wrong, or that aren't right. So be a little bit careful with this. Okay, going piece by piece, the x-intercept is -2. I agree with this. So that would be true. The y-intercept is -2. There's no point there. That one is false. F is decreasing. I'm going to put a little down slope when x is greater than 2. So x is greater than 2. Well, that's going up. No. F is increasing when x is greater than 2. That means we're going to have a positive slope there. We just said that. So that would be okay. F has a local maximum at -2, 0. That is the maximum. That's the top of a peak. And it has a local minimum. Well, if it has a maximum, it's definitely not a minimum. F has a degree of 2. In other words, this would be an x squared polynomial. We know that x squareds are parabolas. This is not a parabola, so that's a no. It has a degree of 3. Based on what we know, x cubed parabolas are going to look something like this. What you don't know is that there are other, did I just say x cubed parabolas? I meant x cubed polynomials. There are other polynomials that also could look like this, so this is, based on what you know, a yes, but there are other things that could be, so I might be picky about that if I were studying. I'm not going to do something like that too on the midterm itself. And finally, it's negative when x is greater than 2. Well, negative means that we'd be below the x-axis down here. There's nothing there. But it is positive, in other words, above the x-axis when x is greater than 2. I'm going to keep going with these just because these are kind of weird for us. The degree is even. That's talking about what the highest power is again. And anything with an even power is going to both go up or both go down. We talked a little bit about this, but we spent some more time talking about other ways to look at end behavior. In this case, both sides of my graph go down, so we're talking about an even graph, not an odd graph. Positive leading coefficient, that's talking about if we're going up to the right, and we are definitely not here. So therefore we have a negative leading coefficient. Y-intercept of 10, yeah, that looks pretty good. X-intercept y-intercept of -2, nope. 4 distinct zeros, we got 1, 2, 3, 4, that is correct. Has more than 4 distinct zeros, nope, we just found that it has 4. A couple of those are double roots, so they bounce there, but those are not, those are more zeros, but they are not separate distinct zeros. Distinct means different. A bounce at x equals -5, well, we don't bounce there. And a bounce at x equals -2, we certainly do bounce there, so we would mark that one right. Alright, and then for 99, We've got x squared minus 7x plus 6. I might factor this just because it looks like we probably have to. X minus 6 and x minus 1. Okay, degree is even. I see a 2 up there. We are good. Has positive leading coefficient. There's a 1 out front. It is positive. We are good. The graph has a y-intercept of 6. The last number is 6. Does not have intercept 7. The graph crosses the x-axis, okay? I have to find zeros. I'm glad I factored this. That's going to be at x equals 6 and x equals 1. X-axis at 6, not negative 6, and at 1, not negative 1.